Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished exercise 11.5 and the topic was geometric progression and sum of infinite geometric series. Today we are going to start last exercise of chapter number 11 and the topic is, you can see on the screen, further arithmetic and geometric series. So you can say this exercise is a mixture of exercise 11.3, 11.4 and 11.5. 11.3 means arithmetic sequence and series, 11.4 geometric progression or geometric sequence, and 11.5 infinite geometric series. So before I start exercise 11.6 question number 1, first I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder, name is ADMath. Watch previous lectures of this chapter, at least previous exercise 11.5, then you will have good command on this topic. So let's start question number 1, exercise 11.6. The first term of a progression is 8 and the second term is 12. So the first term of a progression means we doesn't know the progression is arithmetic or geometric. So we call the first term is T1, 8, and the second term is 12, T2 is 12. Find the sum of the first 6 terms. First 6 term means S6 question mark, given that the progression is part A, arithmetic. So if the progression is arithmetic, then the first term we call is A, that is 8, and the second term is A plus D, that is 12, and we need to find S6, means the sum of first 6 terms. Why we call T2 is A plus D? Because we can easily find A plus D by using the formula of nth term, that is an is equals to A plus n minus 1 into D. That is why I told you that watch previous lectures. So the formula of sum of arithmetic series is n upon 2 into 2A plus n minus 1 into D. But first we have to find D. This is A plus D. A is 8, 8 plus D is equals to 12, then D is equals to 12 minus 8, 12 minus 8 is 4, D is 4. So S6 means we have to put 6 where we see n upon 2, 6 upon 2, to A is given 8 plus n, 6 minus 1 into D we have find 4. 6 upon 2 is 3, 2 8s are 16, 6 minus 1 is 5, 5 4s are 20, 20 plus 16 is 36, and if you multiply 36 by 3, you will have 108. So 108 is the answer of part A. Now the part B is when the progression is geometric. So when the progression is geometric, we have to say the first term is A, that is 8, and the second term is AR, that is 12. So from here we can easily find r. This implies that a is 8. 8 into r is equals to 12. This implies that r is equals to 12 upon 8. Then 4 3 is 12, 4 2 is 8, 3 upon 2, and 3 upon 2 is greater than 1. So we have to use the formula of sum of geometric series when the value of r is greater than 1. The formula is Sn is equals to a into r to the power n minus 1 upon r minus 1. So S6 is equals to a is 12, r we have just found 3 upon 2 to the power 6 minus 1 upon 6 minus 1 is equals to, sorry, a is not 12, a is 8, I am sorry. So 8 into 3 upon 2 to the power 6. 3 power 6 is 729. 2 power 6 is 64 minus 1 upon 6 minus 1, sorry, not 6 minus 1, r minus 1. R is 3. 3 upon 2 minus 1. 3 upon 2 minus 1 is 1 upon 2. That next 8, taking the LCM of 64, so it is 729 minus 64 upon 64 upon 1 upon 2 means 1 upon 2 means we should multiply by 2. Eight is a 64 and 2 4 is a 8. 729 minus 64 is 665 upon 4, and 665 upon 4 is 166.25, and this is the answer of part B, sum of first 6 terms. First part answer is 108 and second part answer is 166.25. This is the summary of question number 1. Hope you completely understand. Move to question number 2. Question number 2 is the first term of a progression is 25 and the second term is 20. Again we have to write first term is t1 is equals to 25 and t2 is given 20. Given that the progression is geometric, find the sum to infinity. Very easy. So in geometric progression, first term is 25 and second term is AR, that is 20. This implies that A is 25 into R is equals to 20. This implies that R is equals to 25 upon 20 upon 25. 5 4s are 5 5s are 4 upon 5. So A is 25 and R is 4 upon 5. The formula of sum to infinite geometric series is S infinity is A upon 1 minus R. a is 25, 1 minus r is 4 upon 5, 25, 5 ones are 5, 5 minus 4 is 1 upon 5, and this 5 should be multiplied by 25. So 25 into 5, that is 125. This is the answer of part A. The sum of infinite geometric series is 125. Part B is given that the progression is arithmetic. So if the progression is arithmetic, then the first term is a25 and the second term is a plus d, that is 20. This implies that a is 25 plus d is equals to 20. This implies that d is equals to 20 minus 25, that is minus 4. Now read the second part. Given that the progression is arithmetic, find the number of terms. Number of terms means we have to find n question mark if the sum of all terms is minus 1550. So Sn is given in this question, that is minus 1550. So we have to use the formula of sum to n term in arithmetic series. Sum to n term formula is Sn is equals to n upon 2 into 2a plus n minus 1 into d. Sn is given minus 1550 is equals to n is unknown, 2a, a is 25 plus n is unknown, d is minus 4. Okay. Multiply this 2 by minus 1550, it will be minus 3100 is equals to n. 25 2s are 50, minus 4 into n minus 4, n minus minus plus 4, minus 3100 is equals to n. 50, there is the mistake, 20 minus 25 is minus 5. So minus 5 put over here, minus 5 put over here. So minus 5n plus 5. Sorry, this is the mistake. So 50 plus 55 is 50 plus 5 is 55 minus 5n minus 3100, n into 55 is 55n. So 55 into n is 55n. And n into 5n is 5n square. Shift minus 5n square over here, it is minus 5 plus 5n square, then minus 55n, then minus 3100 is equals to 0. Now this is a quadratic equation, but if you simplify this quadratic equation before solving, it will be comfortable to you. If you divide the whole equation by 5, 5 cancel by 5 is n square, 5 11s are 11n, and 5 620, 5 620 is 3100. So this is a quadratic equation. Now you can solve this quadratic equation by any formula, that is by using quadratic formula or by middle term break method, no matter. And I am lefting this work for you. I am writing direct solution. So we will have two values of n. One is minus 20 and other is one is minus 20 and other is 31. But we have to write 31 because n can never be negative. Number of terms are always positive. So our final answer is n is 31. Okay. So hope you completely understand part B. This is question number 2. Now move to question number 3. This is the whole summary of question number 2. Move to question number 3. Question number 3 is the first, second and third terms of a geometric progressions are the first, fifth and 11th terms respectively of an arithmetic progression. So we have two progressions. One is geometric and other is arithmetic. According to question, the first term of geometric is equals to first term of arithmetic. The second term of geometric, that is AR. The fifth term of arithmetic, that is A plus 4D. The third term of geometric, that is AR cube. And the 11th term of arithmetic, that is A plus 10D. I repeat again. The first term, the first, second and third terms of a geometric progression are the first, fifth and 11th terms respectively of an arithmetic progression. Given that the first term in each progression is 48. So the value of geometric and arithmetic, the first term is 48, that is A of geometric 48 and A of arithmetic is 48. And the common ratio of the geometric progression is R, where R does not equal to 1. Find the value of R. Very easy question. Students, first we have to assign the name of this equation is equation number 1 and equation number 2. Okay. Now take equation number 1. AR, A is 48, so 48R is equals to A that is 48 plus 4d. The second is AR square, sorry, because the third term is AR square. So 48 R square is equals to 48 plus 10d. Okay, now we have to solve these two equations to in order to find the value of R. So we have to eliminate d. How we can eliminate d? See carefully. If we short this equation, like this is 10, if we divide this equation by 2, so 2 24s are 48, 2 24s are, and 2 5s are. So now equation 2 is reduced in smaller form. Now take these two equations again, and this equation 48r is equals to 48 plus 4d can also be reduced 48 upon 4, 48 upon 4, 4 upon 4. So 4 12s are, 4 12s are, this is r, 4 4s are, cancel, this is d. Now equations are smaller. Dealing with smaller coefficients are easy than dealing with larger coefficients. Now we have two equations. 12r is equals to 12 plus d, and second is 24 r square is equals to 24 plus 5d. Now I am going to cancel d. How it is possible? Just multiply this whole equation number 1 by 5. So 5 12s are 60 r, 5 12s are 60, 5 into d, 5d, and this 24 r square remains same, 24 5d. Subtract these equations, these terms. Minus 5 plus 5 cancel, 60r minus 24 r square is equals to 60 minus 24 is 36. Shift both r square and r terms on right hand side. It is 24 r square minus 60r plus 36 is equals to 0. Again we have to do division in order to smaller the coefficients. Divide the whole equation by 12. 12 2s are 24, 12 5s are 60, 12 3s are 36 is equals to 0. Now we have again a quadratic equation, 2r square minus 5r plus 3. Solves this quadratic equation by using any method like quadratic formula or completing square or middle term break. You will get the value r is equals to 3 upon 2 or 1. But according to question, r does not equal to 1, so we have to write the only value, that is 3 upon 2, 1.5. This is our final answer. R is equals to 1.5. Part A. The second part is the sixth term of each progression. Before I have to find the sixth term of each progression, first we have to find the value of difference d. We just take equation number 1, AR is equals to A plus 4D. Part B, AR is equals to A plus 4D. A we have given 48, R we have find 1.5, A is given 48 plus 4 into D. So 48 into 1.5 is 72. 72 minus 48 is equals to 4D. 72 minus 48 is also I am dividing by 4 because 4 is multiplied by D, it should be divided over here. So with the help of scientific calculator, 72 minus 48 upon 4 is equals to 6. So D is equals to 6. Now we can easily find the sixth term. So for arithmetic, T6 is equals to A plus 5D. This is arithmetic. A is 48 plus 5 into D we have just find 6. 48, 5, 6 are 30. 48 plus 30 is 78. And now we have to find the term number 6 of geometric progression. So for geometric progression, T6 is equals to AR5. A is 48, R is 1.5 to the power 5. By using scientific calculator, you will have the answer is 364.5. So I hope you completely understand this question. Very easy but little bit long. Move to next question. This is the whole summary of question number 3. Start question number 4. Question number 4 is, a geometric progression has 6 terms. So first we have to write 6 terms of geometric progression. So 6 terms are, first is A, then AR, AR square, AR cube, AR4, AR5. The first term is 486. So the value of A, first term is given 486, and the common ratio is 2 upon 3. The ratio is 2 upon 3. An arithmetic progression has 35 terms. So 35 terms means A plus D, A plus 2D, till A plus 34D. So these are 35 terms of arithmetic progression. The common difference is 3 upon 2. So here D is given 3 upon 2. The sum of all the terms in the geometric progression is equals to sum of all the terms in the arithmetic progression. Find the first term and the last term of arithmetic progression. Very easy question. Let's start. First, we have to write the formula of sum of geometric progression, sum of the series of geometric progression, that is Sn is equals to A into 1 minus r to the power n upon 1 minus r. Why we use 1 minus r to the power n instead of r to the power n minus 1? Because the value of r is 2 upon 3. Okay. Now we have to find the sum of 6 terms, that is S6. A is given 486. One minus r 2 upon 3 to the power n 6 upon 1 minus r 2 upon 3. Okay. So 486 into 1 minus 2 power 6 is 64. 3 power 6 is 729. Upon 1 minus 2 upon 3 means 3 ones are 3. 3 minus 2 is 1 upon 3. So S6 is equals to 486. Take the LCM, 729. 1s are 729 minus 64. 729 minus 64 is 665 upon 729. And this 1 upon 3 should be reciprocal, that is 3 upon 1. After solving the whole terms with the help of scientific calculator, we will get 1330. But the question is, why we have find the sum of 6 terms? One thing, that the geometric terms are 6 in the question, and the second thing is, which is very important, this sum of all terms in the geometric progression is equal to the sum of all terms in the arithmetic progression. That is, sum of all 6 terms are equal to sum of all 35 terms. Okay. Now we have to find the sum of all 35 terms. What is the formula of Sn in arithmetic progression? N upon 2 2a plus n minus 1 into d. Sn 35 terms, 35 upon 2, 2a, a is unknown, n is 35 minus 1, d is given, that is 1.5. Okay. So S35 is equals to 35. Now, according to question, the sum of geometric progression is given the sum of arithmetic progression. This is the main point. So S6 is given, we have find S6, that is 1330 is equals to S35. So here S35, we replace S35 by 1330 is equals to 35 upon 2 to A plus 35 minus 1 is 34. 34 multiplied by 1.5 is 51. Now solve this equation to find A. These two should be multiplied by 1330. Then the answer is 2660. Okay. So 35, 2A plus 51. This 35 divided by 2660. So it is 76. So 76 minus 51 upon 2 is equals to A. And finally A is 12.5. Very important, very genius question. What was the question? Find the first term and the last term of the arithmetic progression. So how many terms are given? Arithmetic, how many arithmetic terms are given? The formula of nth term is equals to Tn is equals to A plus n minus 1 into D. So the last term in the sequence is 35. 35 is equals to A 12.5. N is 35 minus 1 into 1.5. This is also given 12.5. 34 into 1.5. 35 12.5 plus 51. 12.5 plus 51 is 63.5. This is our final answer. So hope you understand entire question. Entire question number 4. This is the whole summary of question number 4. Move to question number 5. Question number 5 is the first, second and third term of geometric progressions are the first, fifth and eighth terms respectively of an arithmetic progression. So again we have geometric and arithmetic. In geometric, the first term is equals to, in arithmetic, the first term. In geometric, the second term, that is AR. In arithmetic, the fifth term, that is A plus 4D. In geometric, the third term, that is AR square. In arithmetic, the a term, that is a plus 7d. The first, second and third terms of a geometric progression are the first, fifth and eighth terms respectively of an arithmetic progression. Given that the first term in each progression is 200, the value of the first term in both the progression is 200, and the common ratio of the geometric progression is r, where r does not equals to 1. Find the value of r. That is part A. So the first part is to find the value of r. So assign the name of this equation is equation number 1 and this equation is equation number 2. Now first we have to put the value of a. So a is 200 into r is equals to 200 plus 4d. We can reduce this equation by dividing each term by 4. 4 5s are 4 5s are and 4 1s are. Again take second equation, ar square, that is 200 r square is equals to 200 plus 7d. Okay, but this equation cannot divide by any number, so we will take this equation as it is. $50R is equals to 50 plus d 200r square is equals to 200 plus 7d. Now we have to eliminate d by multiplying this whole equation by 7. 7 5s are 35, 350r, 7 5s are 350, 7 1s are 70, 200 r square, 200 plus 70, subtract 350 r minus 200 r square is equals to 350 minus 200 is 150, and these two variables are cancelled. So our equation reduced to 200 r square minus 350 r plus 150 is equals to 0. But this equation can be small if we divide the whole equation by 50. 50 fours are 200, 50 sevens are 350, 50 threes are 150. 4r square minus 7r plus 3. Solve this equation by any method, you will have r is equals to 1 and r is equals to 3 upon 4. But there is a restriction in question, r cannot be equal to 1. Therefore, we have to take r is 3 upon 4. R is equals to 3 upon 4 is our final answer. What is part B? Part B is the fourth term of each progression. Part B. Before we find the fourth term, first we have to find the value of D. So we have the equation of R and D. Equation number 1, 50R is equals to 50 plus D. 50R we have find 3 upon 4 is equals to 50 plus D. So after solving it, 50 multiplied by 3 is 150 upon 4. This 50 is subtracted is equals to D. After finding with the help of calculator, you will have the value of D is minus 12.5. Now you are able to find the fourth term of both the sequences. The fourth term of geometric is T4 is equals to AR3. What is A is given 200, R we have find 3 upon 4 cube. 3 cube is 27, 4 cube is 64. With the help of calculator, you will find the value of T4. Your answer must be 84.375. Now we have to find arithmetic. For arithmetic, the fourth term is equals to T4 is equals to A plus 3D. A is 200, 3 into D is minus 12.5. Now with the help of calculator, find the value of 200 plus 3 into minus 12.5. You will get 162.5. This is our final answer. Find part C. Find the sum to infinity of geometric progression. Very easy. Part C. The formula of sum to infinity is S infinity is equals to A upon 1 minus R. A is 200 upon 1 minus R. R is 3 upon 4. 200, 4 ones are 4. 4 minus 3 is 1. 1 upon 4. 200 into 4 is 800. So the sum to infinity is 800. This is our final answer. Hope you understand entire question, question number 5. Here we go. This is the overall summary of question number 5. Move to question number 6. This is question number 6. The first term of an arithmetic progression is 12. So A is given 12 and the sum of the first 16 terms as 16 is equals to 282. Part A. Find the common difference of this progression. Very easy. Find the common difference. So we have to use the formula of sum of arithmetic series Sn is equals to n upon 2 to a plus n minus 1 into d. Sn S16 is equals to 16 upon 2 into 2a. A is 12 plus 16 minus 1. D is unknown. S16 is given 282. 16 upon 2 is 8. 12 2s are 24. 16 minus 1 is 15. 15d. Finally, (282) 8 into 24 is 192 and 15 8s are 120d. Then 282 minus 192 and this 120 should be divided is equals to d. Hence d is 0.75. 0.75. Use calculator properly. Now come to part B. (0.75) is the answer of part A. The first, fifth and nth term of arithmetic progression are the first, second and third term of a geometric progression. So first is arithmetic and second is geometric. The first term of arithmetic is equals to the first term of geometric. The fifth term, that is a plus 4d of arithmetic, the second term of geometric, that is ar, and the nth term, that is a plus n minus 1 into d, is equals to the third term of geometric, that is ar square. Find the common ratio of the geometric progression and the value of n. Hope you understand. So this is equation number 1 and this is equation number 2. I am taking equation number 1. A plus the part B, this is part B, a plus 4d is equals to ar A is given 12 plus 4, D we have find 0.75, A is 12 into R. So 12 plus 4 into 0.5 is 15, and 12 must be divided R. 15 upon 12 is 3 5 the 15 and 3 4 the 12, that is 5 upon R. So first requirement has fulfilled, the common ratio is 5 upon 4. Now find the value of n taking equation number 2. A plus n minus 1 into D is equals to AR square. So A is 12, n is unknown, D is 0.75, A is 12, R we have find 5 upon 4 square. Okay, so 12 plus 0.75 n minus 0.75 is equals to 12 into 5 square 25, 4 square is 16. Okay, so 12 minus 0.75 is 11.25 plus 0.75 n is equals to 12 into 25 upon 16. By using calculator you will have 75 upon 4, you can check, and 75 upon 4 you can also do this. 12 into 25 upon 4 is 18.75. Hence the value of n is equals to 18.75 minus 11.25, and this 0.75 must be divided. Hence the final answer of n is 10. So you must know the proper use of calculator. Hope you understand entire question. Question number 6. This is the summary of question number 6. Let's start question number 7. Question number 7 is, the first two terms of a geometric progression are 80 and 64. So first term of geometric is 80 and second term of geometric is represented by AR 64. The first three terms of the geometric progression are also first 11 and nth term of an arithmetic progression. What does it mean? The first term, okay, first I am writing geometric and arithmetic. Geometric of first, that is A. Arithmetic of first is also given is A. Okay. Then second term of geometric AR is the 11th term of arithmetic, that is a plus 10d. Next, the third term of geometric, the nth term of arithmetic, that is a plus n minus 1 into d. Find the value of n. This is the question. So read question carefully. First, we use this AR is equals to 64 and A is given 80, so we can use this to find the value of R. So R is equals to 64 upon 80. 64 upon 80 is 4 upon 5. So first we have to find the R. Now we have first term of geometric 80 and the common ratio is 4 upon 5. Now use AR is equals to A plus 10D. AR, that is AR, we have given 64. So I am putting 64 over here. From here, this is AR. A is given 80. Sorry, 80. Plus 10D. So 64 minus 80 upon 10 is equals to D. Find with the help of calculator. D is equals to, you will get minus 1.6. Now use this equation. AR square. A is 80. Dot means multiply. R square 4 upon 5 square. A is 80 plus n minus 1 into D minus 1.6. So 80 into 4 square is 16 upon 25 is equals to 80. Minus 1.6 into n is minus 1.6 n minus minus plus 1.6. 80 into 16 upon 25 is 51.2. And this 80 must shift over here. And this 1.6 also shift over here. So on right hand side only minus 1.6 n. So 51.2 minus 80 minus 1.6 is 30.4 minus 1.6 n. This minus cancel by this minus, and n is equals to 30.4 upon 1.6. So 30.4 upon 1.6 is 19. This is the answer of question number 7. Hope you understand entire question. This is the summary of question number 7. Let's start question number 8. Question number 8 is the first two terms of a progression are 5x and x square. So T1 is 5x and t2 is x square. Part A. For the case where the progression is arithmetic with a common difference d is 24, find two possible values of x and the corresponding values of the third term. It is very easy. Students, the first term is 5x and the second term x square. And if this one is arithmetic, it means difference is d is equals to x square minus 5x. And difference is given 24, x square minus 5x. X square minus 5x minus 24 is equals to 0. This is a quadratic equation. After solving this quadratic equation, you will have two values of x. One is 8 and one is minus 3. So 8 and minus 3 is your final answer. And the next requirement is to find the third term. What is third term in arithmetic? T and T3 is equals to a plus 2d. Okay. So first term is 5x plus 2 multiplied by d. D is given 24. So when we take x is equals to 8, first we have to take x is equals to 8. This one. So 5 into x, 8 plus 24 into 2, 48. 5 8s are 40 plus 48. That is 88. Next, T3 is equals to 5 into x. This time I am taking x is minus 3 plus 2 into 24, that is 48, minus 15 plus 48. Minus 15 plus 48 is 33. So the final answer is third term is 33 or 88. This is the answer of part A. Now move to part B. What is part B? For the case where the progression is geometric with a third term of minus 8 upon 5, find the common ratio and the sum to infinity. Very easy. Third term T3. We are talking about geometric. The third term is AR square. Okay. And this 5x and x square becomes geometric because we are talking about geometric progression. So 5x comma x square, when we consider it's geometric, so the ratio is r is equals to x square upon 5x. X cancelled by its square, it is x upon 5. Now the value of third term is given minus 8 upon 5. T3 is minus 8 upon 5 is equals to A is 5x, and R square, R we have find x upon 5 square. Now simplify it. That is x square upon 5 square is 25. 5 5s are 25, and this 5 cancel by this 5. So x square into x is x cube is equals to minus 8. Taking cube root of minus 8 is minus 2. Now come to question. Find the common ratio and sum to infinity. Common ratio are x upon 5. X is minus 2 upon 5. So part B, minus 2 upon 5. And sum to infinity. S infinity is equals to A upon 1 minus R. A is 5x. So 5 into x minus 2, 5 2s are minus 10. So A is minus 10. So minus 10 upon 1 minus R. R is minus 2 upon 5 minus minus plus 2 upon 5. So S infinity minus 10 upon 5 1 is 5 plus 2 is 7. 7 upon 5. 5 tens are minus 50 upon 7. Or you may write it minus 7 whole 1 upon 7. That is 7 1s are 7 7s are 49 plus 1 is 50. 50 upon 7. So this is the answer of part B completely. That is the sum to infinity. So hope you understand entire question, and this is the summary of whole question number 8. I hope you understand this whole question number 8. What is left? Nothing. Good news, the whole exercise has finished in a single lecture. And the second good news is we have finished the whole chapter 11 series. Name is series. The whole chapter 11 successfully. We have completed each and every exercise from 11.1 to 11.6. We did each and every question. We didn't left any part, any question. So I hope you will enjoy a lot for this chapter. But still, if you have any problem in any question, not for this chapter only, but also previous chapter, write in comment box. I will help you. Now in next lecture we are going to start a very important, very interesting, very informative chapter number 12. That is differentiation 1. I promise you I will explain deeply each and every topic of this chapter. So this is our today's class where we finish the whole exercise. So if you like my videos, if you think that my videos are satisfying you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.